remember, the multiply you have to do out by hand. So before you can see if they can be multiplied, get the dimensions. A is a 2 by 3. B is a 3 by 1. These have to be the same. Therefore, the result is a 2 by 1. So when you do this, it's row, column. And then the next row, go down to the next row physically. So you're multiplying and then you're combining those pieces and you get your matrix. You can also check it on your calculator. You put it in your matrices, do A times B, and make sure you come out with the same answer. It's a good way to check it. If we do B times A, remember these are not commutative. The only time they are commutative, if they are inverses. That's one of our ways to check to see if it's an inverse. It will work both ways. So this one is undefined if we go the other way. B is a 3 by 1, A is a 2 by 3. We can't even attempt to multiply those. We say undefined, no solution. D to the negative 1. So all you have to do is put this in and just do inverse, D to the negative 1. Flip it back to a fraction. Don't round those irrational decimals. The bars, remember straight bars, what do they mean? Determinant. So when you see the bars around C, it says, find me the determinant. And you have to be able to find the determinant with a 2 by 2. So you're going to multiply up, subtract, multiply up. And again, you can check it on your calculator. So say you added instead of subtracted or you missed your negative sign, it won't work out the same. So step back and take a look at it. Okay, now this is a good one to work on. How did you guys do with Kramer's rule? Yeah? Everybody got Kramer's rule? Okay, so I'm going to give you one of these. You're going to separate it. You're going to give me your coefficients and your constants. Remember, you're going to give me the determinant of your coefficients. This is your big one. Then you're going to put it in for row X, row Y, sorry, column X, column Y, column Z. Now, I'm going to take something like this and I'm going to do it 3 different ways. Let's do an inverse one now. Let's solve this using an inverse. How do I set this up to solve to use an inverse? That'll prove they're inverses of each other, but they're not inverses of each other. That's the identity. That's when they are inverses of each other. A to the negative 1 times B. So you already have this set up. Look, this is in your A right now. This is in your B, right? So you're going to do A to the negative 1 times B. And this A to the negative 1 is a 3 by 3. B is a 3 by 1. So your result will be a 3 by 1, which will look like 3, negative 2, 1.
You should get the same answer, right?
You have to get the same answer. But that's what I want to see for your inverse. How easy is that? But you have to remember, A to the negative 1. I'm not asking you to show that they're inverses of each other because they're not. That'll be a different question. We'll do one that are inverses of each other. And then I'm going to ask you to solve using reduced row echelon format. What's the, whoa.
RREF.
RREF. RREF. So how do I solve using RREF? Good. You're going to put the whole thing into one matrix. You're going to include the constants in here. You're going to put this whole thing in. And just like as you said, you're going to do RREF. And that's how your answer is going to come out like this. So that this is your x is on, so x is equal to 3. Y is on, y is equal to -2. Z is on, z is equal to 1. It's like a binary, on, off. 0, 1. 0 is off, 1 is on. You should get the same results, just like Alicia said, with anyone that you do to this system. So I'm going to have you, God bless you, do it using RREF, using inverses, using Kramer's rule. Good? Okay. And did I give you the determinant one down here? Okay. Solve for x. How do I know what they're asking me to do? What do those bars mean? Determinant. So you're going to multiply 5 times 6 minus -3 times -2 is +6. There's your determinant, 24. I'm going to use the determinant to find the area of your triangle. Remember, you're going to take your vertices, and you're going to, because it's not a square, you're going to have to fill the right-hand column with 1s. Don't forget to fill this with 1s. Find your determinant. Your formula says plus or minus 1/2 determinant. It's kind of like, almost like the 1/2 based on type. So it still has the 1/2 in it. Because your determinant came out negative, this time you're using the -1/2. If your determinant is positive, you use the +1/2. Because you always want your area to be positive. No. But I'll need you to recognize that's a straight one. If you see that sitting all by itself, that's equal to x, that you know that's the determinant. I won't take points off from the brackets, but because you're just getting the feel of this. And if I give you two matrices, it's not on here, but if I give you two matrices and I ask you if they're inverses of each other, let me see if I can pull up a matrix. All right, if I give you two matrices, and I say, are they inverses of each other? Let me see if I can pull one up from there. If I give you two matrices, and I say that, show that A and B are inverses, how would you do that? A times B, and B times A, and they both would give you the identity matrix. There's only two. They both would give you its identity matrix. Okay, they both have to give you the identity. If it's a 3, then it's a 3 by 3. And they have to be square. If it's not a square, can't do it. What's another way to prove that they're inverses of each other? If A inverse is equal to B, and B inverse is equal to A. Make sure you go both ways, which will happen anyway. Okay, so I'll also just print out A inverse, print out B inverse. We can do it that way. So that will be there as well. Any questions? So that's a good thing to know first, because then we know we're going to have 3 rows, 2 columns. So this has to check and will result in a 3 by 2. Now, remember, you're going to go row, column. So we're going to take the first row, we're going to multiply by the first column. Then we're going to multiply by the second column, and we're going to stop. So you can see if we do this 3 times, that's what's giving us 3 rows. If we do this against 2 columns, that's what's giving us 2 columns. So, especially for the test, write it out. 3 times 2, element per element, plus 2 times 1. This element, this element, this element. 1 times 4. Put a break, because now you're in the second column. This is what's going to give you 1 column. That one will give you the second column. Second column, 3 times negative 1, plus 2 times 0, plus 1 times 0. You take the break there. So there's your 2 columns. Now, go to the next row. Am I going too fast? Everybody's good? Okay. Row, column, column. So, do it like this because you're going to see if you do anything wrong. Plus 4 times 1, plus 0 times 4. Take a break, go to the next column. 2 times negative 1, plus 4 times 0, plus 0 times 0. Okay? Last one. Row, column, column. So 3 times 2, plus negative 1 times 1, plus negative 2 times 4. Okay. And the last column, 3 times negative 1, plus negative 1 times 0, plus negative 2 times 0. Now, the reason I like to write these all out is because look at your pattern. All of these 2's, all of these 1's, 4's, negative 1's, 0's, 2's, aren't those where your columns come from? And then 3, 2, 1, 3, 2, 1. See it? This is another column right here. This was your column before. All your 2's, all your 1's, all your 4's. Second column, all your negative 1's, all your 0's, all your 0's. You kind of have a little pattern. You'll spot right away if something was off. If something doesn't match, here's your second column. 2, 4, negative 1. Here's your third column. 1, 0, negative 2. You'll know right away if something's wrong. Now, if you want, just put this whole thing in your calculator. 6, even put it in so that your calculator will add them. So 6 plus 2 is 8, plus 4 is 12. Remember, we're going to get 3 rows, 2 columns. Negative 3 and 0, 0. 4 plus 4 plus 0. Negative 2 plus 0, 0. 6 minus 1 minus 8. Negative 3 and negative 3. There's your result. Everybody's good with that? Okay. You guys are ready. You guys are more than ready.